So currently I hope that I am audible and KSP stream has started. आज के स्ट्रीम में क्या करेंगे, मैं फ्री हूँ तो थोड़ा ट्राई करेंगे SSLV रॉकेट बनाना कर्बल स्पेस प्रोग्राम में। चैट में बताना कि लैग आ रहा है क्या स्ट्रीम में। वैसे आना तो नहीं चाहिए इस पीसी पे, इस डिवाइस पे, बट लेट अस सी। ठीक है, ट्राई करेंगे SSLV बनाना। सॉलिड रॉकेट बेस्ड फ्यूल है, मतलब मोटर है उसका SSLV का सभी स्टेजेस ऑलमोस्ट, बट लास्ट स्टेज जो है वेलोसिटी ट्रिमिंग मॉड्यूल वो अलग है। तो मैंने पहले भी एक बार ऐसे ही SSLV बनाया था, मतलब सेम स्पेसिफिकेशन बट नो मॉडेड पार्ट्स। तो वैसा ही कुछ ट्राई करेंगे। अगर कोई स्ट्रीम में ज्वाइन किया है तो बता दो कि लैग आ रहा है क्या। इफ देयर इज एनी लैग लेट मी सी द चैट इफ पॉसिबल। चैट शुड मूव अप राइट। यस, ठीक है, लेट अस स्टार्ट। वैसे भी बहुत फ्री हो आज। फाइन, let's start in vehicle assembly building, right? What we will do is we will be making sure कि ये जो details है इसके SSLV के वो actual rocket को correspond करे। तो मेरे पास फ़िलहाल कर्बल स्पेस प्रोग्राम 2 नहीं है, which is the thing। KSP 2 नहीं है, KSP 1 है मेरे पास, फर्स्ट वर्जन। KSP 2 के लिए तो नहीं है उतना मेरा स्पेक्स पीसी का। दिस इज़ अ 12 GB डेस्कटॉप, सो 12 GB पे तो नहीं चलेगा रैम पे। Definitely, I guess minimum requirement is 16 GB and optimal performance के लिए the requirement is about 32 GB। तो उतना रैम तो डेफिनेटली बहुत रेयरली कोई डेस्कटॉप या सेटअप में होगा। गेमिंग प्रोफेशनल गेमिंग सेटअप के लिए होगा उतना रैम। बट वो लोग ने आगे का सोच के गेम को बनाया, मतलब आगे के 6 से 7 साल या 10 साल तक गेम को खेल के सके ऐसा बनाया। सो दैट इज़ द रीज़न कि वो लोग ने अच्छे स्पेक्स रखे और हाई क्वालिटी का गेम रखा है। अपने के लिए उतना ज़रूरी नहीं, तो SSLV नाम रखते हैं क्राफ्ट का। एंड ठीक है, इसको सिमिलर बनाना है एक्चुअल मॉड्यूल के। तो कमांड के लिए अपन पॉड यूज़ करेंगे, राइट। फॉर द कमांड वी विल यूज़ सम सॉर्ट ऑफ पॉड। प्रोटो स्टे पटनेक नहीं, दीज आर गुड। रिमोट गाइडेंस यूनिट, अगर हम डायमीटर देखें SSLV का, सो स्मॉल डायमीटर, राइट। कितना डायमीटर अपने को देखना चाहिए। लेट मी ओपन द PDF एज वेल। तो PDF मेरे पास है यहाँ पे। PDF देख के वी विल डिसाइड हाउ मच ऑफ डायमीटर वी आर सपोज टू कीप। अगर किसी को पता है SSLV का एक्चुअल डायमीटर तो कमेंट सेक्शन में बताइए, सो दैट अकॉर्डिंगली वी कैन मेक चेंजेस। ठीक है, सो अगर किसी को पता है, एंड ऑल्सो लेट मी नो इफ़ द ऑडियो इज़ फाइन। ठीक है, बिकॉज आई एम नॉट श्योर इफ़ माई वॉइस इन नेगेटिव डेसिबल्स। -20 इज़ फाइन, राइट। ठीक है, तो पहले डॉक्यूमेंट में खोल लेता हूँ। ओके, let us open this and let me share check it out first। ठीक है, accordingly we will decide कि करना है या नहीं इसको। ठीक है, if you guys want to see, let me switch and show you the document as well। okay, document दिखाना है तो I'll have to do window capture, right। हाँ, yes, okay, and I'll have to hide him। okay, fine। So this is a document about SSLV rocket। so let us see the technical details। ये I guess न्यू स्पेस इंडिया लिमिटेड ने रिलीज़ किया था डॉक्यूमेंट। इसमें we can see the fairing diameter which is 1900। so that is a 2 meter fairing, is it right? 2 meter fairing है, right। तो ठीक है, fairing 2 meters कर देते हैं। let us see यहाँ पर कितना है diameter। आई एम नॉट श्योर अगर KSP मेंशन करता है स्पेसिफिक डायमीटर्स और टॉलरेंसेस है। डायमेंशंस कहाँ पर होंगे? हाँ, वी विल नो फ्रॉम फेयरिंग, राइट। फेयरिंग है इन एरोडायनामिक्स। ओके, सो हियर आर द फेयरिंग्स, राइट। वेयर आर द फेयरिंग्स एंड पेलोड? yes, okay, so this is a 2.5 meter fairing and it does match with this, right। तो इसका मतलब ये जो हमारा कंट्रोलर है ये this is fine and this will stay above and the fairing will go below। वी विल मेक सम चेंजेस एज वेल. फेयरिंग फ़िलहाल निकाल देता हूँ. अगर आप ऑब्जर्व करोगे तो SSLV का जो अपर स्टेज है वेलोसिटी ट्रिमिंग मॉड्यूल, मैं इधर आपको दिखाता हूँ. ओके, मे बी यू आर नॉट एबल टू सी कर्बल्स दिस प्रोग्राम, राइट? Yes, you are not able to. Let me show you game capture. Okay, fine. So let me open the chat as well. Fine. ठीक है. So अगर velocity trimming module को देखें, it looks very specific here. This looks very specific, like this has certain tanks in it. Let me show you the velocity trimming module. Okay, let me do one thing. Let this go below, this go below. Okay. सो ये जो यहाँ पर आप देख रहे हो ना, यहाँ पर देखो बहुत सारे कंपार्टमेंट्स है. देर इज़ दिस पर्टिकुलर सेपरेशन रैक एंड देन देर इज़ फेयरिंग एंड थर्ड स्टेज मोटर इज़ ऑल्सो हियर. सो थर्ड स्टेज मोटर इज़ आउटसाइड द फेयरिंग. इसके लिए ये कुछ ऐसा अरेंजमेंट ये लोगों ने किया है. मे बी वी विल डू द सेम. ठीक है. सो वॉट वी विल डू इज़ विल ऐड दी स्मॉल टैंक्स ओवर हियर. there will be a small round structure and there will be sat separation place. So we will make a satellite as well for SSLV then. ठीक है. Let me switch to Kerbal space program now. Okay, let me shut this down. Let's see क्या fuel tanks मिले अपने को. हाँ, these are actual fuel tanks. This is what the fuel tank actually looks like, right? ऐसा ही दिखता है SSLV का fuel tank. So इसको यहाँ पर रखते हैं. We should make a radial symmetry and 4 of these will look good. Which fuel is here? Okay, these are liquid fuel and oxidized. Okay, I thought ये monopropellant है. Fine. So ये रखते हैं. But we will need more fuel. So what I'll do is ये जो donut है ना, इनको अपन यूज़ करेंगे. We will use these donuts as well. By the way, these donuts are small sized. I'm not sure if this is the actual size. I'll have to see. Let me see the solid rocket motor. This is a thumb back booster. Oh, I understood the problem now. We have taken a larger diameter controller. We'll have to delete all of this and we'll have to start with a smaller diameter controller. This is a 0.1 ton module, right? And this is a 0.5 ton module. Okay, so this is our SSLV's diameter, actual diameter. Very small actually. ठीक है. What we will do is now इसके ऊपर फ्यूल टैंक डालेंगे पहले तो. ओके, four fuel tanks. Oh, these are more than enough for it. So what we will do is now just switch to these ones because बहुत बड़े हैं वो. ठीक है, तो उसको नीचे रखते हैं फ्यूल टैंक्स को. We will need 4 of these. Two up, 2 below. ठीक है. This is good. इसके ऊपर we'll have a sat separation module. So support में कुछ तो रखते हैं. Okay, I guess this is it, right? हाँ, ठीक है. एंड इसके ऊपर एक सैटेलाइट भी हमें डिप्लॉय करना चाहिए. हाँ, दिस इज़ गेटिंग टू मच बिग ना. वी शुड रिड्यूस द साइज बिकॉज एक्चुअल सेपरेशन मॉड्यूल नहीं है, राइट? I don't want 8 of these. I want a sequel with this won't work. This might. Okay. This adapter might. Perfect. इसके ऊपर अपन सैटेलाइट प्लेस कर सकता है. सो सैटेलाइट स्पटनिक जैसा करे. विल लुक आइकॉनिक. स्पटनिक मॉड्यूल इसको. ठीक है, फिर इधर डॉकिंग पोर्ट्स देते हैं. डॉकिंग पोर्ट्स नहीं, आई गेस सेपरेशन विल बी बेटर, कपलिंग विल बी बेटर. I'll need the most smallest of the couplings. Yes, this is it. Perfect. Okay, so this is a coupling and अभी यहाँ पर we'll attach the battery, should we give controls, मतलब ne- what will you call them, which engines are those? I forgot its name. Ion engines, okay. Electric propulsion system, okay. Electric propulsion system दे इस पे. This will look cool, right? So we will be able to change the orbit of a satellite. I'm not sure ऐसे payloads actually में इसरो launch करेगा, but we can try it, right? Okay. So इसको requirements होगी गैस की and electricity की, right? So इसको gas लगेगा and we will find it maybe here. No, this is navigation light. This is dome light. Where are the gases then? Science? No. Okay, in the fuels itself, I guess. This is a holding tank. Okay, this is a xenon container. We'll need, oh, these are big. These are big. We'll need a smaller container. Oh, this is fine. This is fine. And we'll provide a battery as well. Okay. So battery will be in electric, right? Yes. These radial batteries are good. This is 5 times larger, right? This is 5 times larger. So this one should do. And we'll provide solar panels. So solar panel should be circular. So okay, these are 1/6 models, so it will look good. Gives radial symmetry, and three of these, three are covering it. We'll need four. Four will be better. Okay. Okay. There would be a little bit of background noise, and I'm sorry for that because I live in a house. So, ठीक है होगा. Okay. These are. Oh, this is something different. I've never tried these panels. Okay, there are circular solar panels as well, it seems, but no, we do not have enough space for that. So these are the solar panels. We need antennas as well, right? Communication के लिए. Let's give these directional antennas. These ones. Okay, four. Okay, four of these. ठीक है. This will form a directional array. We don't want another directional antenna. We want a controller here, right? Let's give that Sputnik wala thing. So it will look iconic, like it will look like actual Sputnik. Okay, so finally we have our payload. These are the panels. This is an electrical propulsion system. There is a xenon tank as well. Shall we give reaction control system? No, we should give a stability assist system. Okay. We will find it in utility, right? Okay, I guess utility or cargo. No, not in cargo. Control, command and control. Okay, yes, command and control. This is the section. No, these are bigger modules. We'll need a smaller module. This is even bigger. Okay, this one. This is a small inline motion module, so we can change the orientation easily, right? And then we have the Sputnik. So yes, I guess our satellite is ready. Our velocity trimming module is ready. Velocity trimming module will need engines as well. So we'll need small engines. I guess these are good. Spider liquid fuel engines, right? Yes, these are good. We should see the design. I mean, if you check out the PDF from NSIL, you will see कि चार बहुत बड़े engines हैं. I mean, चार main engines हैं which point upwards, and then for maybe stability or maneuvering, they have got two or I guess three other engines. In total, four other engines which are directional. So you can actually change the orientation of this velocity trimming module with the help of those. But what we are going to do is we are going to add all eight in a single direction, in upward direction, right? So what that will do is we can actually increase our total velocity. And because हमारे पास यहाँ पर ये system है gyroscope control के लिए, because of that what we will be able to do is we will be able to maneuver or make changes in the direction without the need of those thrusters in other direction. So this is the change which we are making, unlike the traditional engine, and the specific reason for it is better control. Okay, now I think that maybe using these engines is not a this fuel tank is not a good idea. The reason is because, well, it is consuming a lot of space first of all, and then there is free empty space inside. So the free empty space could actually be utilized. It looks good, it has got an appeal of its own, but then we are using a lot of space or wasting a lot of space as well. Maybe we can add an equipment inside that space. What I'll do is I'll remove this, keep it here. In this space I'll add something. I'll add something of say science. Okay, but how will I access it then? Shall I add a fuel tank here? Okay, shall I add a fuel tank? This tank? A single tank? No. Okay, not this as well. What shall we do? Shall we remove these completely? And okay, well, let's do one thing. Let's remove these, place this directly upon here so that we can have the separation module, and in the bottom side we'll add another engine. So what will happen is, or we can add a fuel tank as well in the bottom section. So what that fuel tank will do is, that fuel tank will provide us excess fuel basically. I guess there are these very thin tanks. Okay, this is a heavy one, this is another heavy one. This looks good. Nope, these are big. We'll need those small fuel tanks which are liquid fuel and oxygen. This is only liquid fuel. Nope. There were these small fuel tanks, right, which had both liquid fuel and oxygen. These lack oxidizer. Okay, these have oxidizer. These are extremely heavy. As said, these won't work. This looks good. Perfect. This one will do the job. What shall I do? Shall I remove these and add a fuel tank inside? No. Let me do one thing. I'll add a communication equipment from downside. So what that will do is, just like इसरो ने किया था, what इसरो did is, इसरो ने अपने जो PSLV का इंटरस्टेज था ना, उसको एक नाम दिया, which was poem. And what they did is they added a communication antenna inside of it. What that did is, okay, I'm not able to add the antenna in this configuration. What I'll do is I'll flip the entire craft. Okay, hold. Okay, remove, add the antenna. Okay, antenna added. This is a directional antenna here. We'll need solar panels as well in that condition. Okay, so how will we provide space for solar panels? Okay, again another idea is to remove this part. See, I'll take a lot of time making these changes, because, well, that's the fun, right? That's the fun of getting the details right. This is an adapter, right? So I've repurposed an adapter here. What I should do is, I'll remove this and then I'll get free space here. Okay, and I'll add solar panels on this free space so that I can power the antenna and I can actually do some science. right? So solar panels for here, no, these won't work, these are gigantic. Will these work? These would also not work. We'll need smaller panels. These ones, once deployed, cannot be retracted, and these are also big. Okay, what about these? Perfect, these are perfect. Okay, okay, perfect. uh, 4 of these, if wanted 8 as well. So no, 4 of these, and the rest of the space would be occupied by communication equipment or some science experiment. 2, 3 and 4. 3, 4. Okay, 4. Fine. So we have 4 of these which we will deploy once satellite separation happens. And in the science equipment bay, let's add something else. Let us add something interesting. Okay, there's a nice accelerometer. We also need to make sure, right, that the amount of sensors which we are adding in have enough space, because if you observe, most of these sensors will take a lot of space, and we do not actually have a lot of space here. As you can see, the thermometer, one of the smallest equipment, actually is consuming so much of space. So we'll have to be careful on that part, right? Making sure that it does not consume a lot of space. Fine. So there are 3 sensors here currently, and I guess we can add the blue color dustbin as well. Yes, grav roll detector. Okay. So we have 4 sensors, we have a transmission antenna. So we have actually replicated what ISRO did, right? ISRO ने जो बनाया था poem module, that is what we have replicated actually here. uh, Now we'll need a separation module. Okay, this is it, the velocity trimming module, an invented newer version with actually better advantages. And अभी एक बार ये हो जाए तो the rest of the part is easy. It's actually very easy. So we'll need a separation mechanism for this. Should we keep the entirety of this in the fairing? Yes, we'll have to, right? ठीक है. So this is a 1.25 meter fairing. Perfect. Okay, I hope that the fairing will also get separated. Okay, this looks something like this. Okay, we'll increase the length, because many people are actually not aware कि जो fairing होता है, it does not directly close. There is a lot of free space given to make sure that your equipment, okay, it does not get heated. It is kept distant from the end. ये थोड़ा सा pointed हो गया, I'll have to change it. Perfection is necessary, right? So okay, maybe that is fine. Fine. And color is same, right? Color is the same. Now we can use the entire equipment, we can move it upwards. Okay, let's go up. Fine. So this is it, this is done. Let's now add some components to it. So first of all, what we will do is we will add a solid rocket booster. The solid rocket booster will be for the third engine. And let me now switch to the NSIL PDF. Okay, so in this particular NSIL PDF, there is information given about specifics of this. So if you see the third stage, SS3, it has a, I guess, 4-ton solid rocket motor. Yes, a 4-ton solid rocket motor. We are going to do the same thing. We are going to use the 4-ton solid rocket motor here. Okay, and that is it. Okay, fine. Let's go and add the 1-ton motor. 3-ton or 4-ton, right? I'll have to search for a 4-ton motor as well. Okay, in engines we'll find it, right? Okay, this is a 7-ton booster, point 0.8, 0.3-ton booster. Oh, these are interesting. Okay, I guess this is the one we want, right? No, this is a 70-ton booster. Oh, a 144-ton booster. That's great. But I'm still not able to find the booster that we want. I guess this is it. Hammer solid rocket booster. This is about 3.45 tons, which is close to what we want, right? Fine. So we have the third stage in. Now let's add a coupling. Okay. The same coupling will go here. Yes. No, this one won't. Fine. Okay. Now the second stage is actually of a 7-ton booster. So this thumper booster will do the job. So this is the second stage, and again we'll have to add a coupling. See, as I told you कि एक बार initial काम हो जाए उसके बाद बहुत easy है SSL को बनाना. Initial जो process है ना, that is time consuming, as in making the satellites and the velocity trimming model, because that is actual difficult rocketry. The solid engine part has been well mastered over years by militaries for their defense purposes. So now let's move on to the first stage. So जो KSP मैं खेलता था उसमें the problem was कि the first stage was of 20 tons maximum solid rocket booster, and in here with KSP with the actual SSLV, the first stage had a much larger tank with a much larger requirement of propellant. So I'm not sure about the exact size, exact weight. I think it was two and a half times of the one which I was using. So that means, yes, I guess 120 ton is the total mass of the rocket. This particular thing is maybe 70 tons or 90 tons. 90 and 7, 97 tons. Then we had 4 tons, so 97 and 4, 111. Okay, so I guess this one was 90 tons. So what we will do is we'll add a 90 ton rocket motor. 90 ton motor is difficult to find. Okay, 2.5, so 24. Okay, this 70 ton motor will do the job, but I guess it has a larger diameter as well. That will be a problem, right? This is huge. Just look at this thing. No, this won't do. This is too huge. Like SSLV has been converted to something completely else. This won't work. We'll need a same diameter motor with a higher mass. I'm not sure if I will find one here. This is a 71 thoroughbred, 144 ton motor. Oh, that will make an SLS, space launch system. This one will do the job, right? This is a 24 ton booster, by the way. I'm not sure why these things do not align where they are supposed to. Finally. Okay. So yes, I guess this is a rocket. The entire rocket. Yes. This does not actually look like an SSLV. I agree to that part because, well, it is much longer than SSLV, but that is because the diameter is lesser. So yeah, this should work. This is definitely an overkill. This will inject the rocket in much higher altitude, but now we are still lacking a technical detail, and let me show that to you. So if you observe this PDF, let me show you the PDF now. in this PDF you will see that there are these four aerodynamic airfoils, and then there is an opening over here. So this is an actual detail in the rocket, and these are actually self-stabilizing, spin stabilizing systems. So these will spin and stabilize the rocket. We have got those struts, those outlets, but we do not have those aerodynamics and aerodynamic wings right over here. Let us add those then. I mean, if you observe, there are some very small struts, but those won't do the job, right? You need something which will be actually visible and which will actually keep the rocket stable. Uh, do we have some wings for that? We have this. We have this winglet. Four of these will look beautiful. And because of their orientation, these will actually keep the rocket stable. Like, look at this. Oh, maybe wrong placement, but yes, this will actually spin stabilize the rocket. This should actually spin stabilize the rocket. Do we have anything else? Okay, we have these. Perfect. These look even better, and these are perpendicular, right? If you observe, SSLV actually looks like a missile, more of a missile, but never mind. Now we have a flag of ISRO as well, right? I think we have a flag of ISRO with us. I'm not sure why they've not provided a flag of ISRO, but I think I added a flag of ISRO personally, but maybe I'm not able to find it now. Never mind. Let's use NASA then. This is not done. There is Rocket Lab. There's Electron. Okay, let's accept Electron, and let's add the flag on the rocket as well. There is nothing big enough. Okay, this is fine. Why is it so distant? I do not understand that. Okay, these are flags, right? We need stickers. Cargo won't do the job. To size 0 tanks. This is for size 1 tanks. I guess this is a size 1 tank. No, maybe these are not size 1 tanks. We'll add one single flag, right? This flag is actually taking more time than it should have. Okay, let's change the polarity. Okay, now that should get applied. Perfect. Okay, this is not done, definitely not done. We wanted an SSLV flag or an ISRO flag on this system, but yes, for now we'll manage with it. Now let's go to the launching structure support thing. We are not going to use any launch pad here, but we have these things. So two of these perpendicular will do the job. I'm still not getting why they are okay. We'll add a radial symmetry then, and two of these will do. Okay, fine. So we have the radial symmetry. We have this. We have our SSLV rocket almost completely ready, I guess. The fairing looks smaller than the rocket, so let's edit the fairing. Okay. Let's increase the length. Okay. Uh, this fairing construction is actually taking seriously more time. Okay. This is not done. This is overkill. We'll have to build fairing. Okay. Build fairing. The first part. I'm not sure why this is taking so much of time. We will need a fairing, but why is it taking so much of time? Uh, let's try again. Build fairing. That is the thickness. Okay, done. We'll have to make this straight. The shadow of the rocket actually helps in designing this. Let's make it look falcon. This just looks like icy beam, but fine now. Okay, this definitely does not look like SSLV, but it's still a rocket, and I'll work on the fairing part later. Fine, I should launch the rocket as soon as possible. Let us. Okay. We have changed the window capture, right? We are loading a game. Okay, game seems to be loading. I'll increase the game volume now because it's time for liftoff. And yeah, let's see. Oh, this is night time. Actually, good. No SSLV rocket launch has happened ever at night time till date. So it's definitely going to be an interesting launch. I have activated the reaction thrusters, reaction control system. The stability assist system has been activated. Let's switch on to the map view. We have a little some satellites here. We have a few satellites over here currently, and that is because this is a completely new game. This is a new game on my rather newer PC, which I'm currently playing. The previous PC had a lot of games, and I did not save that particular game because that was not from Steam. I got it from my friend, that particular game. So that's the reason it was not saved, and I regret that. But now let's move on to the launch. There is not going to be any throttle control because this is a solid rocket propellant. But then too we will have a liftoff, and the liftoff will be in 3, 2, 1, launch. So here we have our liftoff of SSLV D2. The rocket is actually accelerating very slowly, and I'm not surprised. Maybe the payload is actually very heavy, considering we have added a lot of things. And this particular solid rocket booster, which actually weighs 24 tons, is currently lifting a total mass of about 112 tons. And that's very easy for a solid rocket booster because of the high thrust to mass ratio. But then again, it has a very much lower efficiency and a very much lower specific impulse. Let's change our wave to the space lab, and now just above it we can actually see the uh, arm of Milky Way. And look, we can see a moon as well. Moon is actually visible from here. We won't be making it to moon with this particular rocket here, but then to moon is actually visible. I'm not sure if you guys are able to hear because I've zoomed out. So if I zoom in, you guys will be able to hear the propellant burning. I can accelerate. I can accelerate time, but I guess that's not a good idea now. Delta V. Okay, let's see our delta V currently. Okay, we are getting a delta V of 1001 meter per second. The start propellant was 30.2 ton, and burn has been of 38 seconds. The remaining burn is of 37 seconds actually. So let's hide all of this information. I guess we are going through max Q currently because there is a need for stability assist currently, and the reaction control system was activated. I can hear it from the audio here. We're not able to see the plumes, and by the way, very stupidly we actually forgot to add reaction control systems. But then it's fine because we are planning for a low earth orbit, right? So that's fine. Let's see our apogee. Where are we actually heading? Moon is here. mm, how much of an altitude we have actually reached by now? Okay, so we have reached about 13,000 kilometers, 13,000 meters, I'm sorry, that is 13 kilometers, 16 kilometers, 17 kilometers, and increasing rapidly. I guess we will make it to maybe 30 kilometers with this. See, we are actually entering max Q. Uh, because this is night time, we are not able to clearly see the rocket, and maybe I should have launched it at daytime, but that's fine currently. Okay, once we make it to orbit, everything will look beautiful. We will move to the day side. I'll make sure to move to the day side once we move into orbit. Okay, so we have already crossed 43 kilometers. I guess we'll make it to 50. Yes, we have crossed 50, 55, 56, 50. Yes, we have crossed at 60, and we are very rapidly decelerating now. So because this is KSP1, we'll have to add our maneuvers very quickly, right? Let's do it very fast because we don't have much time to waste, right? Okay, I think I should ignite the second engine as well. Use the delta V. Okay, ठीक है. So separating engine 1, second stage ignition. I'm not sure if we should do that, but okay. Second stage ignition successful. We are currently loading on the second stage, and our apogee is continuously increasing. Maybe we'll make it to about 120 with this second stage. A periapsis is minus 598.51 kilometers. Apoapsis or apogee is 890 kilometers. Yes. Okay, we have made it to 100 kilometers, and that's the problem with a solid rocket motor, because we do not have any control during this time. If I try to actually change the orientation of this particular rocket, what will happen is we will uh, we risk a lot of, I mean, we actually risk changing the direction so badly, or tilting towards one direction so much that we can actually tilt completely downwards, and the rocket will start spinning. I mean, that's what actually happens in Kerbal space program a lot of times. By the way, we have now crossed about 240 kilometers, 260 kilometers, 270, and maybe we'll make it to 300. Okay, just short of 300 at 294, our apoapsis has ended. So now I will have to detach the second stage first. Okay, so second stage detachment successful, and now we'll have to change the orientation. Okay, I'll add a maneuver here. Okay, and we need to make it to orbit now. This is time to make it to orbit. Okay, this won't be a basic orbit. I mean, this won't be a orbit parallel to the equator. I'll try as much as possible to do that, but considering our launch orientation, it's a little difficult. And as I said previously, a solid rocket booster does not give you much control. Let's keep an apoapsis of say 550 kilometers, because that's the claimed apoapsis or apogee of SSLV. 550 kilometers then. Okay, 550. Okay, 600. Okay, fine. We have a apoapsis of 400. We'll have to make it to 500. There's no option on that. Fine. We have a periapsis of, okay, 550. Let's move on to the node burn. The node burn is in 3 minutes and 20 seconds, and the burn time is 26 seconds. Considering that and the burn time of this particular, let's see the burn time. Okay, we have another engine here. That's interesting. Which engine is this? Have we got an engine here? Like, this is definitely going to be it. These are the 8 engines which are inside the fairing. Which engine is this then? Okay, this is an iron engine then. What we should do is, we should add this here and move it upwards. I'm glad that I saw that. We'll do sat separation different from fairing separation. So we'll first separate the fairing, then we'll do the sat separation later according to what we want. Okay, the burn time is, okay, the burn time is 2 minutes and 6 seconds. Okay, we should hurry. Okay, we are in the launch orientation and ignition. Okay, so we have done something wrong. Okay, we'll have to shut down this engine. Okay, maybe we did the wrong thing. First of all, I think we should do a fairing separation. Okay, fairing separation in 3, 2, 1. Okay, then another wrong thing here. I'm glad that the fairing has not separated. Fine. So we are currently rolling at very high speeds. You can see this actually looks cool. If this would have been daytime, this would have looked even cooler. The rocket actually trying to gain orbital velocity, right? And this particular propellant, the output or the stream or the flow looks very beautiful. Oh, but this actually ran out of fuel even before the node could complete. Fine, no worries. What we'll do is we'll deploy the fairing now. We have deployed the fairing. Now I think it is time for. Okay, I think we have done a very bad mistake, terrible mistake. We have not added a separation module here. So what we'll have to do is we'll have to ignite these engines. Fine. So this is how the velocity trimming module looks like, right? The 8 engines, and if I roll the rocket, this is how it will look. These liquid fuel rocket engines are going to do the job for us now. These are the engines. This is what velocity trimming module on SSLV also looks like, the 4th stage. The burn time is decreasing, right? We will make it there, but that will take time as it seems. We gone through half of the fuel. We are very slowly making it to the orbit. Then we'll make the final trajectory changes, and finally we will be in orbit. I'll have to zoom out a bit. The reason I'm zooming out from the craft is because, oh wow, that's the photo that one wants. See, our SSLV 4th stage and the Milky Way strands in the background. That looks beautiful. I guess it's 7:55. We have been streaming for about an hour, and this definitely looks beautiful. Let's see our trajectory and are we fulfilling it. This is taking a lot of time to make it to orbit. The node time is 35 seconds. Okay, and the burn time is 31 seconds. So now let's move on till wait on till minus 15 seconds, and then we will give a final burn, because the velocity trimming module has not got much juice left, to be very frank, and we want it to be also in orbit. So here we go. This should place us in orbit as soon as possible. Okay, the burn time is 25 seconds, and I'm not sure if that with the remaining amount of fuel we will be able to make it to that particular burn time. Okay, 18 seconds of burn time. We have reached a periapsis of 51,000, 52,000, 59, 60,000, 70 kilometers. Okay, fine. We are going good. We are going good. I think we will be able to make it to our target, and I want you to see the corrections which will be happening now. The flight will make a lot of corrections. Okay, X. We have got a periapsis of 124,000. So we'll have to add a maneuver here. Okay. Oh no, that was bad, I guess. Maybe we lost communication. No, we did not. We can add a maneuver here, and in this maneuver what we'll do is we'll no. No. So this should be our final trajectory with 5,700 kilometers, and the current aquasis as 897 kilometers. This is fine. So considering this, the burn time is 11 seconds. Let's move on to the maneuver. We've not got fuel enough fuel left for a maneuver of 11 seconds, but what we will do is we will try our best. So first of all, let's wrap here. I'm afraid we do not have a communication link currently. Maybe if we can use the satellite currently in orbit to establish a connection. No, that satellite is too far away, but we have got ground stations, so that is a good part. Okay. The burn time, the node is in a minute. So let's wrap to the time. Okay, we should do ignition 5 minutes before. And now that the fairings have been separated, I think we should deploy the solar panels. Extend solar panel, extend solar panel, extend solar panel. And yes, this is how our actually 4th stage looks like. This actually looks beautiful. See, just check it out. Okay, we have done something very terrible. Okay, these are rotating, so that is fine then. These are able to rotate, that's the good part. And now we'll have to extend these solar panels as well. Okay, so we will be getting enough solar energy. Okay, we are out of fuel finally. So now the final stage will have to make its journey on its own. So we are going for a separation now. We are going for a separation, and we have a separation. The separation was violent because we deployed the solar panels previously, which was definitely a mistake. Now we have a single solar panel powering the entire setup here, which is the velocity trimming module. And the point is that we cannot retract these solar panels. So once I did that step, I knew that we have made a terrible mistake, right? And then there is an antenna as well over here. We won't be able to use it. Fine. Now what we are supposed to do is we are supposed to move to the debris part. So there are two stages here, right? The probe is also here. So this is the probe that we are looking for, and we'll activate. Okay, so now what we are going to do is we are going to control from here. Okay, fine. We are going to decrease the throttle. And we are going to activate the engine. So we have activated the engine, and now we can extend our solar panels. Okay, so we will be getting electric charge now in our batteries. Now let's add a maneuver. So is fine. A burn time of 44 seconds will make us to that orbit. So considering that we do not have a stability assist system now, right? We'll have to make it to our burn. Okay. So we will increase our throttle now and change directions manually. So that's an interesting part now. Okay. Okay. Very slowly we'll have to change directions. Okay. This is difficult. This is difficult. We are going towards the burn, but because of the lack of a stability as a system, now we can go to full throttle. This actually looks good. This should what the fourth stage of an SSLV rocket will look like. This is what it should look like. Now as you can see, we are not in the correct orientation, but what I'm doing is whenever I reach close to the burn, I am increasing my throttle because anyways we are in orbit. So we are very slowly, we will decrease our speed and we will be in the right place. Okay. 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 We should stop the spin. This is difficult. We have encountered a problem here, and that is we are getting out of electric charge constantly. We'll extend the third solar panel as well. So currently we are running completely on the solar charge which we are getting. So deploying the third solar panel would definitely increase the rate of flow of charge, the total amount of charge generated as well. And I think we are accelerating. We are making substantial changes to our velocities. Okay. We should have had a stability assist system because this is Sputnik level model. Okay, we do not have it. Okay, we are just going to complete our burn. see what altitude we have reached. Oh no, I think we have uh, not sure where we are. Okay, and what is this, and why is it heading towards Earth? Why is it not in orbit? The poem stage is not in orbit. No, it is in orbit, fine, but currently we are not in stable orbit, fine. That won't be an issue, but you can clearly see that this looks great, has got a lot of features inside, and I think this is right time to end the stream. It was actually fun to make this particular thing, and the game has also been saved, so